Hello and welcome guys to my YouTube channel. In today's video we will be explaining compound interest. Now let's start explaining how does compound interest work. Let's say you had $500 and you invest them at a rate of 5% annually per year, and of course this is compound interest, and you invest for, let's say, 3 years. Okay, so the way this works is that firstly, in year 0 you have $500. This is the beginning of the year where you invest. Now, in year 1, you would have basically, you would calculate what is 5% of 500, and it will give you 25, and so you will gain 25. So this will be, you'll have 525 in year 1. Now, so far, it might look the same as simple interest. However, in the next year is where it differs. You see, in the next year, you no longer gain 25. You gain 5% of the 525. So you gain money based on the money you have right now instead of a consistent amount, right? So you would be gaining $26.25. So this is the money that will be added to you. So it will be, you will have 551.25, right? And in the next year, you will also gain 551.25 multiplied by 5%, which will be 27.5625. So this is in the third year, you will gain 27.5625, right? So you will end up having, let's see, you'll have 578.8125. This is the amount of money you have in the third year. So for this percentage, for this interest, interest rate, you will get more money with years. So technically it is better than compound interest. With the compound interest, with the simple interest. With the simple interest, every year you'll only gain 25. It's a constant gain every year. After 3 years, you'll end up having 575. But here you'll have 578. I hope this was clear. Now, of course, it would be impractical to do this for a large number of years. So we have a rule to just simply find the compound interest. And the rule is as follows: A is equal to P multiplied by 1 plus R over 100 power n. Okay? And now R is the interest rate. P is the original amount or the principal amount you invested. N is the time. It could be years, months, or days, but it's mostly years. And finally, A is the final amount. Okay, so we need to understand that this rule will give you the final amount of money you have. It will not tell you the interest you received, only the final money. So to know how much interest you've received, you would subtract the original amount you had from the final amount. This way you would find the interest. So let's take a look at this example. It will clarify what we're trying to do here. Okay, so Emma invests $1,000 in a savings account that offers an annual interest rate of 5%, compound interest. Now, how much money will Emma have after 4 years? Okay, so let's see with part A. So we know that the original invested, or the principal, is $1,000, and the interest rate is 5%, so R is equal to 5. compound interest, and how much money will she have after 4 years? So n is equal to 4. So you go ahead and write the rule, which is a is equal to p multiplied by 1 plus r over 100 power n. And we will substitute our variable. So a is equal to 1000 multiplied by 1 plus 5 over 100 power 4. Okay. And let's fix that. Okay. And now you just go ahead and plug this on the calculator. So and we get that the amount is equal to 1,215.5. Let's do this to one decimal place. So this is the amount of money Emma has after 4 years. Okay. Now, in part B, how much interest did Emma receive? So if you remember, if you've watched the simple interest videos, we said that interest alone is an amount of money, which is how much interest, how much money did you receive? It's different than the interest rate. Interest rate is a percentage. So he's asking for the interest. So how much money did I receive over my investment period? Well, the interest is basically the original amount you had, the final amount minus the original amount you've had. So the final amount was 1,215.5 minus the original being the money you invested, which was $1,000. So 215.5. This dollars. This is the amount of interest you've received over the 4 years. I hope this was clear. Okay, moving on. So now you need to really understand the differences between the rules for simple and compound interest. If you haven't watched the simple interest video, I would highly recommend you go and watch it first. Now, let's see. So Emma and John have $1,000 each. Both of them want to invest into a bank. We have Bank A and Bank B. Now, Bank A offers a 3% compound interest per year, while Bank B offers a 5% simple interest per year. Now, Emma decides to invest into Bank A, while John invests into Bank B. Okay. Both of them invest for a total of 5 years, so N is 5 for both of them. Now, how much interest did Emma receive? Okay, now, let's take a look at the information about Emma. So we know that Emma is investing $1,000. This is the principal amount for her. And we know that she's investing into Bank, let's see, Bank A. Yes, Emma is investing in Bank A. So we're talking about R is equal to 3. And this is compound interest. And the amount of years she's investing for is 5 years. Right? So she's going to invest for 5 years. So now he's asking how much interest did Emma receive. So with compound interest, the way we could do this is firstly, we need to find the amount she has after the 5 years, because the rule is A is equal to the principal amount multiplied by 1 plus R over 100 power N. And the amount will be $1,000 multiplied by 1 plus 3 over 100 power of 5. So the amount will be, we will go ahead and plug this on the calculator. And we get 1,159. Okay. I will be solving this to the nearest dollars, no decimal places. Okay. So this is the amount she received. Now, they're asking how much interest did Emma receive. So how much interest did Emma receive? Well, the interest will be the final amount she had minus, which is A, minus P, being the original amount she invested, which is 1,000. And so she had $159. This is interest. This is the interest that Emma received. This is for part A. Okay? Now for part B, we're being asked how much interest did John receive? Now, the information that we know about John is that I wrote his name wrong. Okay. The information we know about it is that he's investing into Bank B a simple interest with the original amount being 1,000 and R being 5% and N is 5 as well for 5 years. So for simple interest, we used to calculate firstly the interest. Interest is equal to original amount, principal amount, multiplied by the rate over 100, multiplied by T. So interest is equal to $1,000 multiplied by 5 over 100 multiplied by time, which is 5. And we can just go ahead and plug this on the calculator. And we will get $250. So here's the thing. This right here, this is the interest. That's it. This is part B. The simple interest rule gives you the interest at first. Now, so part C is asking, what's the total amount of money John has after 5 years? So the total amount of money John has would be the original, so amount total would be the original that he invested plus the interest he received. The original he invested was 1,000 plus the interest, which was 250. So he gets $1,250. This is the amount of money that he has, the total amount of money. What's the total amount of money Emma has after 5 years? Well, total amount is basically for Emma, it's A, simply A. So it's 1,159. We already found that at the beginning of the question right here. All right. And finally, what's the difference in interest received between John and Emma? Well, that's part E. So here's the thing. So the interest received by Emma was 159 and the interest received by John was 250. So the difference would be 250 minus 159 and it would give you $91. This is the difference in interest. I hope this was clear. So what you need to understand is that the rule for the compound interest versus simple is that the rule for compound at first gives you A, which is the total amount. The total amount of money I have. If I want to know how much interest I received, I would have to do the total amount, the final amount, minus the original amount or the principal amount I've invested. This will give me the interest. However, with simple interest, you have I is equal to P multiplied by R over 100 multiplied by T. This gives you the interest at first directly. And then to know the total amount, you would add the principal or original amount plus the interest that you received. Okay, so I hope the differences between compound and simple interests are clear. Now let's move on to some examples. Okay, let's see. So James wants to have $5,000 in a saving account after 10 years. The account offers an annual interest rate of 4% compounded annually. So this is compound interest. How much should he initially invest? So the information that I know is that the original amount, I need to find this, and we have the final amount, we have the N, and R. Okay. Now, R is 4%, so it's 4. N is 10 years. And we need to understand that James wants to have 5,000 in a savings account after 10 years. So this is the final amount that he wants to have. So this is 5,000 right here, the amount. The principal amount is unknown right now. This is what we want to find. He wants to know how much should he initially invest. So let's go ahead and write the rule. A is equal to P multiplied by 1 plus R over 100 power N. And so 5,000 is equal to P multiplied by 1 plus 4 over 100 power 10. Now look, in such a case, the easiest thing to do is to simply plug this entire expression right here on the calculator and find its answer, okay? So if you plug it, it's going to give you P multiplied by 1.48. And there's also a bunch of decimals. Now, of course, you need to keep your solving accurate, okay? So I will simply write 1.48, but what I will plug on the calculator will be the accurate version using the answer, the ANS on your calculator, okay? So then we would go ahead and find P by dividing through by 1.48 by 1.48. So P is equal to 5,000 divided by, as I said, on your calculator, you should plug 5,000 divided by ANS, the answer, where the answer is 1.48 and there's a bunch of more decimals. So we get 3,377.8. Now the question did not state a unit of round, so we will go with 3 significant figures as usual. So 3,300. Now this is the first significant, second significant, and this is the third. And we have a 7 on the right, so this will get rounded up to 8, and this will be 0. So $3,380. This is the original amount that he should invest to have 5,000 after 10 years. Okay, moving on to the next example. A principal amount of 4,500 grows to 5,000. Okay, so this right here is the principal amount, and this is the final amount. This is A. In 3 years, so this is N. In a savings account with interest compounded annually, so we're dealing with compound interest, what is the annual interest rate? Give your answer correct to 2 decimal places. Okay, so we know P being 4,500 and A, which is 5,000, as well as N being 3. And what we want to know is R, actually. He's asking for the annual interest rate. Okay, so let's go ahead and plug our numbers into the equation. A is equal to P multiplied by 1 plus R over 100 power N. And we're going to go ahead and substitute. So 5,000 is equal to 4,500 multiplied by 1 plus R over 100. R is unknown and N is 3. Okay, so how would we solve this algebraic equation? The first thing to do is to get rid of the 4,500. So we are going to divide through by 4,500. Right, so 5,000 divided by 4,500 gives you 10 over 9. Now you need to keep your answers accurate, okay? Don't write this as a decimal. Keep it accurate. Always keep your figures accurate until the last step. This is when you round. Now, don't accidentally remove the bracket. The bracket is still there because you have a power of 3 right here, okay? And the way we're going to cancel this power 3 is by taking a cubic root. Now, on the right-hand side, we have 1 plus r over 100. On the left-hand side, you can take the cube root for 10 over 9. However, the calculator won't give it to you accurately, so you should just keep it as cube root of 10 over 9. Leave it as it is. We'll round at the very last step. Now, we're going to subtract 1. This will be the cube root of 10 over 9 minus 1. And this is equal to r over 100. And finally, we're going to multiply by 100. And so r is equal to. So now you can go ahead and plug on your calculator, firstly, the cube root of 10 over 9, which should give you around 1.03, and then subtract 1, and then multiply that answer by 100, and you should get 3.574, so on. We should be rounding to 2 decimal places, so finally r is equal to 3.57, and of course percent, because the interest rate is always in percentage. That's it. I hope this was clear. Okay, let's take a look at another example. A savings account has $7,000 and an annual compound interest rate of 6%. How many years will it take for the account to reach $9,000? I forgot. Here there should be the word reach. Okay. Okay. So let's take a look at what we have. We have the principal amount being 7,000, and the rate being 6%, and we're being asked how many years will it take. So we don't know n. For the account to reach 9,000, this is the final amount. I mean, this is the final amount to reach. Okay. So we're gonna go ahead and write the rule firstly. A is equal to P multiplied by 1 plus r over 100 power n. And we will substitute our variables. So 9,000 is equal to 7,000 multiplied by 1 plus 6 over 100 power n. Okay. Now, how would we solve such an equation? So the thing is, you could solve it with logarithms, but it's too advanced for your level at this point. So we're going to be doing it with trial and error, okay? Because when you have n unknown up here, the power, you need logarithms to solve it. Now, how would we do this with trial and error? Well, it's simple. You see, the years are integer values. They can only be 1, 2, 3, 4, and so on. So we would try each of those numbers until we find a value that either gives us 9,000 or exceeds it. Let's see how this works. So you would go ahead and plug on your calculator. Let's try, for example, 1, okay? So you would go ahead and say 7,000, 1 plus 6 over 100, power 1, okay? And you can go ahead and plug this on your calculator. It gives you 7,420. So after 1 year, you will have this amount of money. Is it more than a 9,000? No, it's not. So we need to try other numbers. So to do this quicker, you can just say when n is equal to 2, and a will be, which is the final amount, and you go ahead and plug the exact same thing on your calculator, except change the 1 to a 2. So we would get 7,865.2. Again, we did not exceed it. So now, when n is equal to 3 years, and you plug 3 instead of the n, the amount will be 8,337. Again, did not exceed or equal to. When n is equal to 4, a is equal to 8,837. Again, did not work. And then finally 5. When n is equal to 5, a is equal to 9,367. So we found that this, after 5 years, it will take the account to reach 9,000 or exceed it. So a is n is equal to 5 years. Okay. This method is called trial and error. Okay, and you should be using it when you don't know the power, when the power is unknown. I hope this was clear. Now, you could do this faster by simply substituting like 2, 3, 4 much quicker on your calculator, and then writing the answer that gives you what you want. Okay. Let's take a look at this final example. A sum of $5,000 was invested in a savings account that offers an annual interest of 4%, compounded annually. So this is compound interest. The interest earned on this investment after a certain number of years was 1,248. Calculate the number of years the money was invested. Okay, so this right here is the principal amount, and this is the rate. And let's see here. The interest earned on this investment after a certain number of years was 1,248. So this right here, this is the interest that I earned. Calculate the number of years the money was invested. Now let's go ahead and write the compound interest formula. So A is equal to B Okay. Now let's substitute our variables. So P is 5,000. And we have 1 plus R. R is 4 over 100. And power n, which is unknown. Because he wants the number of years, okay? Now the amount. Be careful. The 1,248 is not the amount. You need to remember, the variable that you substitute here is the final amount of money that's in the account, or the money that you have. This right here is the interest received. Now, how would I find the amount? So, as we know, there is a rule for interest, which is for compound interest. The interest is basically the final amount you have minus the original, okay? So the interest being 1,248 is equal to the final amount minus 5,000, the original amount. So then you would add 5,000 to both sides, and the amount you have is 6,248. All right, so this right here is the full amount of money that you have. You could do it on using the rule, or if you understand it pretty well, you can just go ahead and just say, okay, so I had 5,000, and this is the interest I received. So obviously, the final amount would be 5,000 plus 1,248. If you're confident using this, that's perfectly fine as well. Okay, so we're going to go ahead and write our variable right here, 6,248. Now, this example is similar to the previous one, where we don't know n. So we should use trial and error. All right, so let's see. So let's say when n is equal to 1, right? And we go ahead and plug on our calculator 5,000 multiplied by 1 plus 4 over 100, power 1. We get 5,200, okay? Now, this is not the final amount I want to reach or higher than it. So n is equal to 2. We go ahead and plug 2. 5,408. If you feel like your numbers are moving slowly, take double steps. So let's say, I'm not going to say now n is 2. I'm going to go ahead and say n is 5. So when n is equal to 5, we get 6,083. Okay, that's just a little below what I want. I want 6,248. So when n is 6, this will most likely give me what I want. When n is 6, we get that the amount is 6,326. So this is more than the amount I want to have. So that's it. This is the answer. So n is equal to 6 years. Okay. Most of the time you will exceed the amount of money. It's rare that you actually get the exact same because you see, you receive the interest at the end of the year. So at the end of year 5, you have 6,083. Okay. Now during the 6th year, technically you will have 6,248, but you won't receive the interest until the end of the year. At the end of the 6th year, you have 6,326. So if you're being asked how many years would it take me, well, it wouldn't take 5 because 5 you won't have the amount, but it would take 6 years. You will have a little more than the amount, but that's the answer. So it's 6 years. Okay, so moving on to some examples. Sophia invests $3,000 in a savings account that offers an annual interest rate of 4% compounded annually. How much will her investment be worth after 6 years? So this right here is the principal amount, and this is the rate, and this right here is n. I forgot, by the way, if you don't know, when you have an exercise, you should pause the video, try to solve it on your own, and then check your solution. Anyways, so yes, so P is equal to 3,000, and R is 4, and N is equal to 6. So we want to know how much her investment will be worth. So what's the total amount of money she has? So A is unknown. So we're going to go ahead and say A is equal to 3,000, which is P, multiplied by 1 plus 4 over 100 power of 6. This is fairly straightforward. You just go ahead and plug in your numbers on the calculator, and we get A is equal to 3,795.95. Now the question did not ask for a certain unit of rounds, so we go for 3 significant figures. This is the first, this is the second, and this is the third. Now we do have a 5 on the right, so this should become 10. So it becomes 0, and we carry over a 1 right here, so 8. Okay? So we get 3,800. This is the amount that her investment will be worth after 6 years. Moving on. Try to pause the video and solve this. Now, Alex wants to have $8,000 in a savings account after 7 years. The account offers an annual interest rate of 5% compounded annually. So this is compound interest. How much should he initially invest? Okay, now Alex wants to have 8,000. Okay, so this is the amount he wants to have. This is the final amount he wants to have. So this is A. In a savings account after 6 years, so this is N. And we have the interest rate being 5. This is R. How much should he initially invest? So we're being asked about the original amount, the principal amount. So we're going to go ahead and substitute in our compound interest formula, which is A is equal to P multiplied by 1 plus R over 100 power of N. I'm just going to erase this. Okay. So 8,000. Let's erase this to give more space. So 8,000 is equal to P, which is unknown. It's what I want to find. 1 plus R being 5 over 100 power of N, which is 7. So the way we're going to do this is to evaluate this entire expression on the calculator. So we're going to go ahead and plug 1 plus 5 over 100, power of 7. So like I said in the examples, you're going to get like 1.407 and a bunch of other decimals, but you should be using the accurate. So we're going to use the answer on our calculator. So equal to 8,000. And now we're going to divide through by 1.407 by 1.407. This cancels out and we get that P is equal to, we're going to go ahead and plug on our calculator 8,000 over ANS, the answer, the previous answer, okay? Where ANS is 1.407 along with the other decimal places. So we get that P is equal to 5,685.45. Now, the question asks us to give our answer to the nearest $100, okay? So if you take a look here at the figure, you have, this is the dollars, this is tens of dollars, this is hundreds of dollars, and this is what you want. So the 6 has an 8 on the right, so it will become 7, and everything else will become 0. So P is equal to $5,700. This is rounded to the nearest 100. Hopefully this is clear. Okay, let's take a look here. Joan invests $2,500 into a savings account with interest compounded annually. 4 years later, he receives $650 interest. What is the annual interest rate? Okay, so let's take a look at what we have. We know that he invested 2,500. This is P. This is the original amount. And we're dealing with compound interest. 4 years later, so 4 years later, so N is equal to 4. He receives $650 in interest. So this is interest. So I is equal to 650. Now remember, when you have the interest and you have the original, you can obviously find the final amount. So the final amount is fairly obvious. It's 2,500 plus 650, which gives you 3,150. This is the final amount. So now we're being asked, what is the annual interest rate? So what is R? We're going to use our rule. Substituting our variables. So this is 3,150 is equal to 2,500 multiplied by 1 plus R over 100 power of N, where N is 4. So now we want to solve for R. Like we've said and discussed in the examples, you go ahead and divide by 2,500. We're going to plug the left-hand side on the calculator. Keep your answers accurate. So this is 63 over 50 as a fully simplified fraction. Those two numbers cancel out, and we have 1 plus R over 100 power of 4. Okay. Now, to cancel out the 4 right here, we're going to take a fourth root. So we're taking the fourth root of 63 over 50. This is equal to. So on the left-hand side, we get like 1.0594 and a bunch of more decimals. Okay. On the right side, 1 plus R over 100. Now, like we've said before, you need to keep this accurate, okay? So you can write it as 1.0594, but on your calculator, you should use the ANS, the answer, okay? So it stays accurate. So now we're gonna subtract 1. So R over 100 is equal to. So what you should be plugging here on your calculator is your answer, so ANS, minus 1. Okay, this is what you should be plugging, not 1.0594. We need to keep getting the correct and accurate answer. So we get 0.059, and there's also a bunch of more decimals. And finally, to get r alone, we're going to multiply by 100 and get that r is equal to, again, you multiply your answer by 100. Keep everything accurate. I get 5.947. Okay. So now he wants us to round this to one decimal place. So rounding this to one decimal place, we have the 9 being the first decimal. And we have a 4 beside it, so it will not get rounded up. It will stay as 5.9. So the final answer is 5.9% rounded to one decimal place. Now let's take a look at the next question. A savings account with a principal of 10,000 grows to 12,500 with an annual interest rate of 3%. Okay. Compounded annually. How many years did it take for the account to reach this amount? So we don't know the number of years. We don't know n. But we know the original amount, and we know the final amount, and we know the rate. Okay? So the rule is that amount is equal to original multiplied by 1 plus r over 100 power of n. Substituting our numbers, so 10,000 is equal to 12,000. Oh, sorry. I accidentally switched the numbers. 12,500 is equal to 10,000 multiplied by 1 plus 3 over 100 power of n, where n is unknown, right? So this is not clear right here. This is supposed to be 10. Okay, so again, so the n is unknown. So as we've previously stated, we're going to do this with the trial and error. So we're going to go ahead on the calculator and plug 10,000 multiplied by 1 plus 3 over 100 power of 1 at first. Let's see how much money we will have after 1 year. So when n is equal to 1, you have $10,300, okay? Now, when n is equal to 2, we have 10,609, okay? So we're going to start taking double steps because it's way too slow to do it. So we're going to go and plug n is equal to 4. When n is 4, we have 11,255. We're getting closer. We're going to plug n is equal to 6. So when n is equal to 6, we get 11,940. Let's plug n is equal to 8. Okay, so when n is equal to 8, we have 12,667. Okay? So this is when n is equal to 8 years. So, but here's the thing. What if when n was 7, you actually reach the amount? You see, we want the minimum number of years to reach this. So what if n equals 7 had, let's say, 12,500? We don't know. So just in case, you should try to substitute the number before it. So let's substitute 6. I mean 7. We're going to go ahead and again 10,000 and power of 7. So when n is 7, the amount is 12,298, okay? So no, we didn't exceed it at 7 years. It's exactly at 8 years, okay? We did this step to make sure that we didn't accidentally skip the year. You see, you always want the minimum year, because then I can just say, okay, well, n 100 years. You will definitely exceed it then. But I want to know what year will I reach my target, the earliest year. So 8 years. This is the final answer. Okay, last two exercises. A sum of $4,000 was invested in a savings account that offers an annual interest rate of 6%. compounded annually. Compound interest again. The interest earned on this investment after a certain number of years was 1,040. Calculate the number of years the money was invested. Okay, so the sum is 4,000. Firstly, that was invested at the beginning. This is P. So P is equal to 4,000, and the rate is 6. And the interest that we earned was 1,040. Okay, so this is the interest. And again, if we know the interest and we know the previous or the original amount, we can find the final amount, which is the addition of those two variables, those two constants. I mean, right here, and we get 5,040. This is the final amount. So if we want to calculate the number of years, so n is unknown. So I'm going to go ahead and say that a is equal to p multiplied by 1 plus r over 100 power of n. And a is 5,040 equals to p, which is 4,000 multiplied by 1 plus 6 over 100 power of n, where n is unknown. So again, n is unknown. We're going to go ahead and do trial and error. So we're going to substitute on the calculator 4,000 and 1 plus 6 over 100, and have n is equal to 1 at the beginning. So let's see what that gives us. So this gives us an amount of 4,240. I'm already going to go to 3 years because no way will 2 years give us the right answer. At 3 years, we get 4,764.064. I'm going to go to 5 years, see what that gives me. Okay, so at 5 years, we actually get 5,352. Okay. But again, I said that if you take double steps like this, like right here, we skipped 2 years. Okay. You need to check that 4 years does not already give you the amount you want. Okay. So just in case, we're going to go ahead and check 4 years. At 4 years, you will have 5,049.907 with a bunch of decimals. So actually, we found out that at 4 years, you did exceed the amount by $9, right? So 5 years was not the answer. It was 4 years, okay? So final answer is 4 years. This is the amount of time it would take, okay? So this is why it's really important that when you first exceed the amount and you're taking double steps, you should check just the one before it, okay? Check 4. It might be the previous answer. Final exercise. A sum of 8,500 was invested in a savings account at an annual interest rate of 4% compounded annually. So this is R, 4, and this right here is the principal amount, 8,500. The interest earned on the investment after a certain number of years was 1,200. Okay, so this is the interest. Okay, this is the interest earned. Calculate the number of years the money was invested. So honestly, this is the exact same idea as the question before it. 8,500. This is the original amount. R is 4, and the interest is 1,200. Of course, our rule requires the amount, the final amount, and we can find it easily by adding the original amount plus the interest received, which will give you 9,700, okay? And we want to know how many years, the number of years the money was invested. So n is unknown. I'm just going to go ahead and write the formula with the numbers already. So 9,700 is equal to 8,500 multiplied by 1 plus 4 over 100 power of n. And again, n is unknown. We're going to go ahead with trial and error. We're going to plug this part of the equation on the calculator with n is equal to 1 at first. Let's see what that gives us. So 8,500 and multiplied by 1 plus 4 over 100 power of 1. So we get 8,840. Okay. I'm going to go ahead and go to 3 directly. N is equal to 3. So we get 9,561. I believe n is equal to 4 should give you the answer. So we're just going to go ahead and plug 4. So 9,943. This is the amount of money I would have after 4 years. And it exceeds the 9,700. So that means during the 4th year, at the end of the 4 years, you will have this amount of money. Okay? So 4 years, that's the answer. You don't need to check back because we didn't take a double step here. We only take one step. So it will take me 4 years for the interest to reach 1,200 or higher. I hope that's it for compound interest. I hope this lesson was clear. Thank you for watching.